Hi everyone, a very good morning to all of you. Today we are going to study the question number 37 that is related to induced EMF, like how to find induced EMF, induced current and the direction of induced current. So it's all about Faraday's law and Lenz's law. So to understand the questions based on this, the very first thing is magnetic flux. So what is magnetic flux? So number of magnetic field lines crossing per unit area. I mean crossing through a cross section. And that mathematical expression only we will take it as B bar dot ds bar or B ds cos theta, where theta is the angle between magnetic field and normal to the surface. That is the first definition you should remember and you should understand. And the next thing is you have to think that how can we change the magnetic flux. So the magnetic flux is given by BA cos theta. That means here by changing magnetic field or area or angle between normal to the surface and magnetic field, we can change the magnetic flux. So delta pi equal to pi final minus pi initial, so that there is a average change delta pi by delta t or instantaneous change d pi by dt. So they can ask anything based on the change in magnetic flux. Now comes the Faraday's law that when magnetic flux linked with a loop changes, then EMF induces. That means EMF induced equal to minus d pi by dt, rate of change of magnetic flux. Then induced current will become EMF by resistance of the loop. This is what Faraday said. He did experimentally observed that the change in magnetic flux causes the electricity in the loop, and that comes from the voltage or potential difference developed. That only he called as EMF, induced EMF. Now what is Lenz's law? Lenz's law says that here he explained the negative sign in the induced EMF equation given by Faraday. So the Lenz's law says that the induced current induces in such a way that it opposes the original cause. That means the external effect. It always tries to oppose the external effect. Like if the external flux is trying to increase, the induced current tries to decrease it. If the external flux is trying to decrease, then the induced current try to increase it, and it will support. So it will try to oppose the original cause always. Now how to find direction of induced current using Lenz's law? With one example, let's take, suppose there is a coil like this. Now here one magnet is there. Let's take south pole and north pole, and it is moving like this. Now on any coil, when there is a external effect, first you find direction of external magnetic field, B external. Like here, the external magnetic field is from south to north, away from the north pole. So rightward. Now next step is check it increasing or decreasing. Now here the magnet is coming closer, so the external magnetic field is increasing, implies external flux also increases. So as external field increases, the induced current induces such that the field due to induced current, that means the induced field, there is an induced current and that also produces some magnetic field, that is induced current, and that opposes this must be like opposite to external field. As external BE decreases, then induced field is in the direction of BE. That is what? Like here in the given case, BE increasing and rightward, so the induced field will be leftward because it tries to oppose it. So now that this is the field direction means the current should be induced in this way like this. So the current will go in this way. So just like this is now it will act like a dipole. Like now this side south pole, this side north pole. So that way in any case you have to find what is the external field direction and you have to check whether it is increasing or decreasing. Then you have to decide the induced field direction accordingly, either in the direction or opposite direction. Then using that, you can find the current induced in the coil by using right hand thumb rule. That is what Lenz law, or that is what the method to find induced current direction. Now based on these things, usually they will ask question. Let's see few questions. Like the very first question, a uniform magnetic field exists in the space B1 I cap, B2 J cap minus B3 J cap. Find the magnetic flux. So magnetic flux means B bar dot ds bar through an area S, it is in YZ plane. So area is in YZ plane means direction will become I cap, perpendicular to the plane. YZ plane perpendicular means X. Then dot product means I coefficient into I coefficient B1 into S plus J coefficient is not there, 0. So K coefficient also 0. So the magnetic flux is B1S. So if you want to find a electric flux or magnetic flux, you need to know what? The scalar product. How to find the scalar product of two vectors. Now the next question. The magnetic flux threading a metal ring varies with time. So they have given the magnetic flux in terms of time, like A T cube minus B T square, where A and B they have given, and also resistance they have given 3 ohm. Determine the maximum current induced in the ring. First EMF induced is minus d pi by dt. That means minus 3 into A value 2. So 2 into t cube differentiation 3t square minus 6 into t square is 2t. Now minus 3 times 6t square minus 12t. Now this is the EMF induced. Now the current will become EMF by resistance. So minus 3 by 3 into 6t square minus 12t. Now that will become 12t minus 6t square. Now they want us to find out maximum current. Maximum current means the first differentiation of current will become 0. Maximum or minimum condition implies 12 minus 12t equal to 0 implies the condition will become t equal to 1 second. So that means indirectly they have given the condition that at t equal to 1 second current is getting maximum. Then I maximum means in the current equation you have to substitute t equal to how much? 1. So 12 minus 6, how much? 6 ampere. So this way you have to use the Faraday's law, you have to use the maxima and minima condition also to find the induced current and then maximum current. Now the next question is a square loop of side 10 centimeter and resistance. Side length is 10 centimeter. So area is 100 centimeter square. and resistance is 0.5 ohm, is placed vertically in the east-west plane. Now a uniform magnetic field, the magnetic field is how much? 0.1 Tesla, is set up across the plane in the northeast direction. Like the plane surface is in this direction, east-west direction, and the magnetic field is along north-south direction. Now, sorry, northeast direction, not northwest. Northeast means B bar is along this. This is B bar. That means this angle is 45 degrees. Now the magnetic field is decreased to 0 in 0.7 seconds. So now the magnetic field decreased to 0. So in a time of 0.7. So the final flux will become 0 and the initial flux is BA cos theta, where theta is 45 degrees. Then you can find the change in magnetic flux first. That is final flux minus initial flux. Then EMF induced is minus delta pi by delta t, where delta t 0.7, and you can find the initial flux because they have given magnetic field, they have given area, they have given theta. Then the induced current equal to epsilon by R, where R also given. Just substitute. But the way of understanding the question is important. What is the direction of surface? What is the direction of magnetic field? All those things makes matter. Like here the plane surface is like this and the magnetic field is at some angle 45 degrees like this. That's why the angle we have taken as 45 degrees because along northeast. Now a current carrying straight wire passes inside a triangular coil as shown in figure. The current in the wire is perpendicular to paper inwards. Find the direction of the induced current in the loop if current in the wire is increased. See here current is increasing. So the wire is inward, that means you can find the magnetic field direction like this. So the magnetic field will be there around like this in the form of like circles. As I increases, as current increases, see, as current value is increasing, as current is increasing, magnetic field also increases. At different points. At different points. But here the magnetic field is B bar is parallel to surface. That is the angle between normal to the surface and B bar, that is 90 degrees, implies flux is always 0. So EMF induced is 0. Because flux is always 0 means there is no change in flux at all. So there is no change in flux at all means the EMF induced is always 0. So here you have to understand that even though the question is big, if you understand the simple logic that as the direction between the field and the normal to the surface is 90, so the flux is 0, so the EMF induced is 0, so that current is 0. Now one last and final question. They have given the flux in terms of time. Flux is varying with time. Then magnitude of induced current and time is 0.25 seconds and the resistance is 10 ohm. Epsilon equal to first minus d pi by dt. So the only thing is you should know differentiation formula. Then it will become minus 12t plus 5 if you differentiate this equation. Then at t equal to 0.25 seconds, the EMF equal to minus 12 into 0.25 plus 5. That means this is minus 3 plus 5, that is 2. Then current equal to epsilon by resistance, that is 2 by 10, 0.2 ampere. So this is the way you can understand and you can solve the questions based on Faraday's law and Lenz law. And one of the very important, because lot of questions they have given from NCERT also. I have given all the assignment questions. See, 5 assignment questions I have given. Also I have given all the NCERT questions. See, let's see. See, 1, 2, 3. So there are 8 questions based on the same topic in NCERT. So you can understand the importance of this topic and please try to solve each and every question. So thank you all of you. We'll continue in the next session with the next topic. Thank you all of you.